Hello and welcome back to Diksha Karnataka YouTube channel, and you are watching your favorite series Sankalp KCET 2026. So if you are preparing for KCET 2026 exam, then you have to start now. Don't wait for the exam to come 3 months, 4 months, 1 month. So if you start now, there is a high possibility that you will get a good rank. I will show you our result, those who have studied from us throughout the year, how much good they have performed in the KCET exam. And now today I will be discussing the chapter current electricity. First two chapters, electric charges and field and electric potential and capacitance chapter, both chapters are completed, and you can go and click on the link below given in the description, and you can check that out if you want, or if you want to start just right now, then you should continue this video. Later on you can go and check that out, all the other videos that I have done in this Sankalp 2026 series. Now this is a part, this will be a 2-part series because this chapter is not super lengthy, but this is a very important chapter for KCET exam. 5, 6, even 7 questions comes from this chapter alone. So this chapter you cannot skip at all. So this is the most important chapter. This is not super huge in terms of concept and in depth of the concept, but this is some concepts you have to remember. There are few formulas that you have to remember. So we are going to discuss everything today. Today is the first part where we are mostly discussing electric current and Ohm's law. In electric current we will see what are we are going to discuss. But before starting that, I will like to request you to join our WhatsApp channel. Again, the link of the WhatsApp channel is given in the description of this video. Here you will get all the notes that you want to study from, the lecture notes that I am doing right now, also the previous year questions that we are going to do in this channel, all the solutions and their explanations, everything you will get at one place. So join the WhatsApp channel now, click on the link below and join today. Now, as I was talking about, these students have studied from us from the beginning, and look at their result. Okay, there are only few of the students' results are there. There are a lot of students, and they only studied from us in our YouTube channel. They have maybe they are studying there in their respective colleges, but they are exclusively attached with us through the YouTube channel. We have done an exclusive interview with them as well, and maybe next year this is your picture that will be here. So if you are still in doubt, don't be in doubt. Start today, start now. Right, now let's look into the chapter division as I told you. So first we are going to discuss electric current, then Ohm's law. In Ohm's law we have limitations of Ohm's law, and then from Ohm's law we also have resistance and resistivity. Okay, combination of resistance. We also going to discuss drift velocity, conductivity, mobility, etc., and obviously we also discuss the electrical energy. This is everything of this part will be covered in today's lecture. Okay, cells in series, cells in parallel, Kirchhoff's laws, Wheatstone bridge, everything else. This part will be covered in the part 2 of the lecture that will come I think day after tomorrow, or whatever, Monday, Wednesday and Friday is physics schedule. So next Monday or Wednesday, whenever it is going live, you will get the next lecture, right? Now let's start with electric current. Let us understand electric current. So far we are discussing 2 chapters where the charges were static, but we said conductors have a lot of free electrons, they can carry a charge, right? So these things we have discussed, but what is the meaning of that we are going to see in this chapter particularly. Okay, so from now on, charges are not static, charges are in motion. Okay, that gives rise to the electric current, which is very important to understand. The net amount of charge Q is flowing across the area in the forward direction in the time interval t, then the current is. So current is basically defined by charge flows per unit time. Okay, I hope you studied in class 6th or 7th standard the basic definition of current. So current, if charge that is flowing through the conductor, suppose we have a conductor through which current is flowing. Okay, in the forward direction means we take generally one direction as forward, other direction as backward. The direction part we will come a little bit later on. To understand which direction current will flow, for that we need to know Ohm's law. Okay, then the current is basically given by Q by T. So suppose Q charge is flowing in time T through this cross section, through this area, then the current is basically given by Q by T, and as you can see, it does not depend on the area itself. Okay, it has a inner meaning, it has a deeper meaning of how it depends on the area, but the definition of current does not include the area in the definition. But in some cases it is very difficult to measure the exact amount of charge and exact amount of time. So what we will do, there is another definition. Current are not always steady, and hence more generally we define the current as follows, which is given by I equals to limit delta t tends to 0 delta q by delta t. Right? So if you have studied limit and if you have studied the basic definition of differentiation, then you should know this basically turns out to be the differential. Okay, so this is a definition, this is the normal general definition that you have studied when you are a kid, right, when you are a small child. So that time you studied this definition. Now you have grown up, so this is the definition for grown-ups. Now if the current is steady, then generally dq becomes q and dt becomes t. That is the basic thing. In case current is not steady, current is fluctuating. Okay, for example, we will later study AC current. Okay, AC current is not constant. So in that case, this is the definition of current in the circuit. Right, now let's see electric current in conductors. So as I was talking about that current was flowing in a circuit. We are talking about conductors having a lot of electrons. Electrons can carry charges, right? So let's see, electric charges experiences a force in the presence of external electric field. So obviously electric field is important in this chapter. Even electric potential is also important. So that's why those two chapters were previous chapters. Now the current electricity chapter, both the concepts are very, very important. Okay, so when you apply an external electric field to a conductor, what happens? Okay, so when you apply electric field to a conductor, the charges flows. Okay, how it flows? Electrons being negatively charged move opposite to the direction of the electric field. So we know that, suppose this is the electric field, and which charge can carry current? Only electrons, because only electrons can move, only electrons are free, only electrons can carry current, which is very, very important point to remember. Now if you apply electric field in this direction, whatever are the free electrons present in the conductor, okay, what they will do? They will experience a force in the opposite direction of the electric field. They will experience a force in the opposite direction of the electric field, and if they experience a force, what will happen? They will start moving in that direction. If you apply force to something, okay, then what happens is that it starts to move. If the force is very negligible, then it may not move, but if the force is sufficient, then it will start to move in the direction of applied force. Metals having a large number of free electrons, these electrons accelerate in the presence of external electric field. Obviously F is equal to ma, so you can even calculate the acceleration. So these electrons starts accelerating in the direction opposite to the electric field. Very important point. They move in the opposite direction in the electric field. This gives to the rise to the electric current. So this is the basic reason of electric current. So if you apply an electric field in a conductor, there are different ways to applying electric field. Even in fact the mobile phone through which you are watching my video, or laptop through which you are watching my video, there also some electric field is applied, and because of that you are able to watch this video in your device, right? Everything nowadays works on electricity, right? Analog systems used to be the things of past. Even your mobile phone, your smartwatch, everything works on electricity. So electricity is very, very important part to understand, and one of the most important concept of current electricity is Ohm's law. This is the basic Ohm's law. Obviously you have studied Ohm's law as well, but from here on we will start to do little bit more than whatever we have done. But basic Ohm's law is still important for your board exams. They will still ask you what is Ohm's law, or what are the limitations of Ohm's law. So these are very, very important. Okay, if temperature and other physical conditions remains the same, the current I through a conductor is directly proportional to the applied potential difference. So we are talking about electric field. Now we are talking about potential. Now we know that electric potential difference and electric field are related, right? If you remember, electric field is nothing but minus dV by dx. That was the relation. In unidirection, in one direction electric field, right? So this is, what is dV? dV is nothing but potential difference. Now in the previous chapter, potential difference generally represented by this symbol dV or delta V, okay, or V2 minus V1, like that, or Vf minus Vi. But from this chapter onward, instead of complicating all these things, we will simply represent potential difference by symbol V only. Okay, the V represents overall potential difference. V will represent potential difference, not delta V. Okay, now why so? That is only because V appears too many times. V appears too many times in this chapter onwards. So that's why voltage, if I say voltage V, that means it is a potential difference. If I say potential V is that whatever you have studied in the previous chapter. Voltage is something which represents potential difference itself. Okay, so from Ohm's law we can say that V is proportional to I, or I is proportional to V. Basically I is proportional to V, that is Ohm's statement. But we know that if X is proportional to Y, Y will also be proportional to X. So from that logic we can write V is proportional to I, or if we want to remove the proportionality symbol, then what we have to do? We have to add equal and multiply with a constant. That constant is called proportionality constant or constant of proportionality, right? The constant of proportionality R is called the resistance of the conductor. Okay, so R is resistance, V is voltage, I is current. So this is the most important formula for this chapter, even though this is very, very simple. But remember, this formula has a different type of applications as well, and in future whenever we come across different applications, this is the basic formula. From that we will develop some other formulas as well. Okay, the constant of proportionality R is called the resistance of the conductor, right? The SI units of resistance is ohm, okay, and it is denoted by the symbol omega. The resistance, it is like a symbol, it's like a cap, okay, omega. This is called omega, Greek letter omega. The resistance R not only depends on the material of the conductor but also on the dimensions of the conductor. So as I said, that area was not directly coming into the expression of I, but it has a deeper inner meaning. That inner meaning, basically that area, whatever it is, the dimension, length, dimension means length, breadth, height, and shape and size of the conductor. So that basically hidden inside this resistance. Okay, the everything related to conductor material is hidden inside the resistance. So for example, if you take a wire of iron and a same looking wire of copper, copper will have less resistance than that of the iron. So it depends on the material, it depends on the length, it depends on the area. Okay, so don't forget that. Now let's discuss about resistance and resistivity. Okay, resistance of a conductor is directly proportional to the length. Okay, I can give you one example that you are driving on a long road, you are going through a long road. Okay, longer the road, more time it will take for you to cover the road, right? If the road is very long, Okay, if you are driving, suppose you are driving in a bicycle or in a bike, or you are traveling in a bus, longer the distance, okay, more time it will take. For example, if you are just traveling from your home to your college, or your home to your neighbor's home, okay, to play some PUBG game, so there during that time the time taken is less. But when you are traveling, say, from your place to your grandfather's place somewhere far, okay, or to some village, or some trip during your vacation, so that takes a longer time to reach, right? Why? Because longer road means longer time. So similarly, longer the length of the wire, more is the resistance. Okay. And secondly, resistance is inversely proportional to the area. Resistance is inversely proportional to the area. Now let us understand using the same example. Now you are driving in a same road, but road is full of traffic. Okay, if the road is, for example, if you are traveling from Bangalore to Mysore through Bangalore-Mysore highway, and suppose there are a lot of trucks and buses are there. Okay, there are two roads. If you are familiar with that route, there are two roads. One is Old Mysore Road and another one is New Mysore Expressway. So if suppose you are traveling via Old Mysore Road is little bit narrower. Okay, and if you are traveling through that, and if there are a few trucks ahead of you or few cars ahead of you, it will be very difficult for you to overtake them and go forward, right? You have to maintain the speed, you have to follow them behind even if they are driving very slowly. But if you are going into the Mysore Expressway, which has a very high speed limit, 100 km/h speed limit, okay, in that expressway, which is a very long 4-lane, 5-lane expressway, you can easily overtake one of the cars whichever is in front of you, okay, and you can cross it over, you can cross the truck that is in front of you, and you can pass it and you can drive little faster, right? So in that case, what happens is that if the area or the width of the road, you can consider this area basically width of the road. So wider the road, it will be easier for you to drive, right? If the road is narrower, then you will not be able to drive through it. For example, Bangalore traffic, right? If the road is narrower, choke point, all the cars are going there and they are getting stuck. For example, if you are traveling to Silk Board Junction, if you know that area, then you can imagine one of the most congested place in entire Bangalore, right? So the narrower the road, it is very difficult for you to cross. So if the area is smaller, the resistance will be high. If the area is bigger, then resistance will be low. By the way, just in this point, I just want to remind you what is the resistance. Resistance is the friction kind. Resistance is like friction which is offered by the conductor to the flowing electrons. So basically the conductor will try to stop the electron which is flowing through it. That is the role of the resistance. That's why it is called resistance. It is resisting you. It is trying to stop you, right? So resistance is the something which is trying to stop you. That's why the term resistance came into the application, right? So R is proportional to L. So longer the road, it will take higher resistance, and if the road is wider, then resistance will be smaller. So for example, if you say that this is a wire and this is a wire, which one will have a higher resistance, which one will have a lower resistance? Obviously this one will have a higher resistance because it is not only longer but also its area is smaller. It has a bigger area and smaller length, so in both cases the resistance of this wire will be much less compared to this one, right? Now when you factor in both the values, so we know that if x is proportional to this is the theorem of proportionality, x is proportional to y, x is proportional to z, then we can say that x is proportional to yz, and we can say x equals to constant k yz. K is called the constant of proportionality, right? This is the proportionality law that we already know. So from there we have directly written that R equals to rho L by A. Now this is a new symbol rho. Okay, what is this rho? Rho is called resistivity. Rho is called resistivity. Okay, resistivity of the conductor. Okay, Now what is the importance of this resistivity? Importance of the resistivity is that it depends on the material of the conductor. It depends on the material of the conductor. For example, I gave you one important example, that iron and copper both having same length, same dimension, but copper will have a less resistance. Why? Because resistivity of copper is very low. Copper, silver, gold, platinum, they generally have very low resistivity, whereas iron, okay, the few other metals, they generally have slightly higher resistivity. Even though all the metals are good conductors, but when choosing a proper material to design a circuit, okay, for example, what you will choose, aluminium or copper? Aluminium is generally cheaper, but copper is slightly expensive. But copper has a less resistance compared to that of aluminium. So if you are using something which is made of aluminium, okay, that component will take more electricity, it will heat up faster. But if you are using a copper core instrument, then copper core will generally take less amount of resistance, and it will also heat up less. Okay, so that's how the depending upon the uses, we choose different materials as conductors. Okay, for very high end sophisticated device, we might use even silver. Okay, silver or gold in some cases as well. Okay, now this is a very applicative question. I will try to answer this question, but before that, first of all, let us read the question. Wire of resistance 3 ohm is stretched to twice its original length. The resistance of the new wire will be. Okay, so so let us understand this question. We have a wire. Suppose we have a wire. Okay, now you stretched this same wire. You stretched the same wire into the double the length. Length is double. So whatever length was there, now it is twice the length. Now it is important to remember that you had only one wire, and if you are stretching that, okay, you cannot create mass. So mass of the material will remain same, conservation of mass. So what will happen when you are stretching the wire? Okay, its area will shrink. Its area will shrink. Why? Because mass is basically density into volume. Mass equals to density into volume. So density is constant, mass is constant, volume should also remain constant. So whatever was the initial, say, area, and whatever is the final area, the volume should remain constant. So this is a cylinder. We are assuming cylindrical for easier understanding. So what will be the volume of this? Volume should be length into area. Similarly, what will be the volume in this case? In this case, volume should be 2L into A dash. Now, as I said, volume is not changing. Volume is not changing. The temperature is constant, so volume is not changing. So in that case, you can say that this is nothing but L into A. Okay, so area will basically become half. So when you are stretching a material, okay, there are the two ways this question can be asked. One way is that it is melt and now reforged into a wire of double length. Okay, so this kind of language can also be used. This is the same question. Same question. Only thing you have to remember, whenever you are stretching this kind of wires, okay, not only its length increasing, but its area is also shrinking or decreasing. Okay, so area will be, if the length becomes double, area will be halved. Okay, there is one more style of question, that length is increased by 10%. Okay, we will see that kind of question in our PYQ section. There was one question came in the last few years back. Okay, 10% increase in area, how much? 10% increase in the length, how much will be the resistance. Okay, there are two ways to do it. Either they can ask you it is shrinked, length is halved. So if the length is halved without cutting the material, then definitely its area will increase. So if you are stretching it, its area decreases. If you are shrinking it, its area increases. So these are the things that you have to remember. Now if you calculate the old resistance, say R1, you will get rho L by A. Right, this is the old resistance. What is the new resistance? R2. Now rho is fixed. Rho is fixed for the given material. So rho will not change. Okay, so rho will be constant. Rho equals to 2L by A by 2. Why A by 2? Because we have calculated the area. So you will get this as 4 rho L by A, or 4 R1. This is nothing but R1. So you see that when you stretch the length double, okay, the area becomes the resistance becomes 4 times. The resistance becomes 4 times. So this is the mathematical background. Now there is a shortcut. Okay, so you have to remember that R new is equals to the factor by which you change the wire. It can be shrinked. In case of shrinking, it will be halved. So if it is said halved, for example, halved, F will become half. For double, F will be 2. Okay, for triple, F will be 3. Okay, so based on the cases, value of F will change. So new resistance is basically F square into R old. So if you remember this, you don't need to do this mathematics every time. Okay, you don't need to do this mathematics every time. You know that the new resistance is basically F square R old. Now what is F here? It is twice. Twice means 2 times or double. So 2 square R old is given by 3 ohm. So it will be 4 into 3, that is 12 ohm. Okay, now some of you may know this trick. Those who don't know, they should remember this. Okay, because when I was interacting with students, many students said that, sir, this concept was taught during pandemic and I was not focused. Okay, I was sitting at home, I was not studying and I did not learn this concept. Okay, for CBSE students maybe this is little easier, but for Karnataka board students maybe they find this little bit difficult. So that's why this is the shortcut formula that you have to remember to solve these questions in 10 seconds. Right, you can solve this kind of question in 10 seconds. This is how you save time. This is very, very important to save time during the exam. Now next we are going to discuss about drift velocity and mobility. These are the very, very important concept. So first let us understand what is drift velocity. So drift velocity is when you apply electric field. When you apply electric field inside a conductor, okay, the electrons which were present in the conductor, okay, they are actually initially they are moving randomly. They are moving very, very randomly. But when you apply an external electric field, in the presence of external electric field, the electrons, whichever direction they are moving, okay, they slowly start moving in the direction opposite to that of the electric field. Okay, so this is called drift velocity. Now those who ever seen a river, if you have ever went to a river, okay, not very violent river, normal calm river, if you see that the water in the river, they flows slowly in one particular direction, right? I hope many of you have seen that during your trips or maybe in your village, that there are some rivers and the river is flowing in the particular direction. Now what will happen, I used to stay in the banks of a river. Okay, my hometown is close to river Ganga, so we used to play with this and we used to make this, okay, a small ship, we used to make that. paper boat, we call it paper boat also. So paper boat, if you float it in the river, what will happen is that they will slowly start moving in the direction which the river is flowing. So if you make a river, also you can try it during rainy season also. If you are staying in Bangalore, then you are familiar. If you are staying in somewhere else also, during the heavy rain, your road becomes a river and the water flows in a particular direction. So you make a paper boat and leave it there, and you will see that the paper boat will start flowing in the direction of the river. So this motion is called drifting, because you are not applying any external force in the boat. The boat automatically moves along with the river, right? So this is called drifting. This motion is called drifting motion. So when you apply electric field, okay, so the electrons, even though they are supposed to accelerate, they do not actually accelerate because of a lot of other things present inside the material. Resistance is there, the attraction of the molecules are also there, collision between the electrons are there. So electrons basically starts moving with a constant speed. Electrons start moving with a constant speed in the direction opposite to that of the electric field, and that motion happens only in the presence of electric field, and that is called drifting. And this drifting is actually carries the actual charge particle from one point to another. Okay, the drifting actually carries the charge from one point to another. Now you will be amazed to know that suppose if I apply an electric field, the current hardly takes maybe microsecond or millisecond to reach from one end to another, right? So for example, if you are switching on the light, okay, how much time it will take? You switch on the light and the light glows. You can barely count it using any stop clock, okay? Immediately, it's almost instantaneous, right? But you will be amazed to know that the time you pressed the switch, and from the switch location, the electron which is traveling from that switch till the bulb, okay, it takes a very long time, okay, minutes, maybe in hours also in some cases. Okay, so how this happening that when you switching on the switch, switching on the light glows immediately, even though the electron actually which is carrying the charge, it takes a very long time to reach, okay, because the electric field that is responsible for the switching on the light and not the actual electron. Actual flow of electron is not super important, but electric field, transmission of the electric field is important. Electric field travels in the speed of light, okay, so that's why it travels very, very fast. So drift speed is very slow, very small value. It is not super big large value, it is actually a small value. Now if you see that drift velocity is given by charge of an electron times the electric field that you apply divided by mass of the electron times the relaxation time. Now what is relaxation time? Let us explain that as well. So as I said, inside the material there are a lot of electrons, not one electron, right? There are a lot of electrons present. Now the electrons basically initially without presence of electric field, they are moving in random motion. They are moving in all possible direction, random motion, like a electron gas. That also we said, right? Electron gas. So during this time what happens is that electrons collide with other electrons. Okay, so this electron was moving in this direction, suddenly it came across another electron and they got collided, and then it moved in a different direction. Again it collided with another electron, it moves in another direction, right? Now between these two collisions, electron generally move in a straight line direction, and the time between two consecutive collision is called relaxation time. If we take average of all such collision, we can find what is the actual relaxation time for a given conductor. Okay, it depends on the conductor to conductor, this varies. So you can calculate the relaxation time. So as you can see that drift velocity is basically minus EE by m into tau. Now what is the negative sign signifies? Negative sign signifies is that drift velocity is opposite to that of the electric field. Drift velocity is in the opposite direction of that of the electric field, right? In another word, the current which is flowing in the circuit, suppose you applied electric field, this is the current, this is the electric field. Current will be in the direction of electric field always. Electrons will move in the opposite direction of the current. Electrons will move in the opposite direction of the current. Electric field and the current direction, that will remain the same. Okay, the current is given by NEAVD. Okay, this derivation comes sometimes, not super important derivation, but I will try to cover that during exclusive PU videos or exclusive revision videos, not in this lecture. Here we are mostly focused on KCET related concept and very important derivation. This is not super important derivation, so I am not going to cover in this lecture today. Okay, so I equals to NEAVD. Okay, now current density, which is very, very important definition. Current density is defined by current per unit area. So it is J equals to I by A. Current per unit area, that is called current density. Very important, the unit of current density is, what is the unit of current, by the way? Unit of current is ampere. Unit of current is ampere. And what is the unit of area? Unit of area is meter square, and it is in division, so it will be ampere per meter square, or ampere meter to the power minus 2, right? This is an objective question, came in 2024 board exam. This was an objective question. Okay, so be prepared for this kind of question as well. So this is an easy question, but still student thought because it's a density, it has to be meter to the power minus 3, and they answered it wrong. It will be meter ampere per meter square. Okay, and if you take current from this expression, you will get that it is nothing but NEVD. N is called number density. Number density means number of electrons per unit volume of the conductor. Okay, again it varies from material to material. E is the charge of an electron, VD is the drift velocity. And if you put the drift velocity's value over here and ignore the negative sign, you can get the current density to be N square by M E into tau. Okay, now mobility. Mobility means how mobile the electrons are, how quickly it can move. From mobility, the term came, right? Mobile, not mobile phone. Mobile phone means you can move with the phone, that's why it is called mobile phone. Similarly, if you can how fast the electron can move is called the mobility of the electron, and it is defined by drift velocity per unit electric field. Drift velocity per unit electric field, so VD by E, and you get ET tau by M. Again we are ignoring the negative sign over here. Now conductivity. What is conductivity? Conductivity is opposite to that of the resistivity. Higher the conductivity, better it is a conductor. Okay, lower the resistivity, better it is the conductor. Higher the conductivity, lower is the resistivity. Okay, so it is basically opposite to that of the resistivity term. Okay, so 1 by rho, it is defined by 1 by rho, and it's given by J by E, and it comes out to be N square tau by M. Now there are few important things. Unit of resistivity is given by ohm meter. Unit of resistivity ohm meter. Unit of conductivity is ohm inverse meter inverse. Okay, so these are the unit. Now tell me the unit of mobility in the comment below. What will be the unit of mobility? Okay, just tell me in the comment below, find it out, and tell me. I will not give you anything about it. Now next is Ohm's law in terms of current density. So current density definition we have already seen. Current density is current per unit area. So now Ohm's law, that is V is equal to IR, can be represented in terms of current density, which will give you a completely new value. Let's see. So we know that from Ohm's law, V is equal to I into R. And what is R? R is rho L by A, right? So from here we can say that I by A is called current density J, right? So we can write voltage equals to J rho L, okay? Or we can also know that electric field, what I told you, it is V by L, V by X, whatever it is the length, right? So V by length. Now as I said, it is V here represents delta V, V represents delta V, and L itself is the delta L, right? So V by L will give you the electric field, or you can write V is equal to E into L. So this is the relationship between electric field and voltage difference, potential difference, voltage. Okay, so if you put that, you will get that E is equal to J into rho. This is not it. We have to simplify even further. J equals to E by rho, or J equals to sigma E. So this is the alternative form of Ohm's law. Very, very important derivation. This derivation is very important, 3 marks derivation, and comes very often, that from Ohm's law find the relationship between electric field and current density. Okay, so this is the another common derivation, and also theoretically important. Here sigma is called the conductivity of the conductor, we already discussed, and based on this formula also there was 1 or 2 KCET question came in the a few years back. Now those questions are nowadays they are coming in your board exams, okay, maybe preparatory, maybe college exams, okay. So don't ignore those questions as well. Let's move on to limitations of Ohm's law. So Ohm's law, even though it appears to be correct and applicable to most of the cases, there are few cases where you will not be able to apply Ohm's law. So what are those cases? First of all, V ceases to be proportional to I. So ceases to be means it stops. So if you see this graph, initially the V and I was proportional, and if they are proportional, their graph will be a straight line passing through the origin. If V and I are proportional, then you are supposed to get the whatever is the dotted line that you can see over here, that is the supposed to be the Ohm's law line, Ohm's law graph. This is for normal. If the conductor always obeys Ohm's law, you will get this straight line like this. But if the conductor does not follow Ohm's law, okay, then what will happen? So if you see that up to almost up to this point, up to this point, it was actually proportional. V was proportional to I, and the graph was straight line. From here on, slowly it start deviating from the straight line path, and from here on, if you see that, it is completely out of sync and it is completely going in a different direction, right? So up to this point, you can say up to this point A, Ohm's law, the conductor was obeying Ohm's law, but after this point A, the conductor is no longer obeying Ohm's law. This can happen due to various factors. First of all, most common thing is the heat. The heat increases the resistance, and it can keep on increasing the resistance. So heat increases the resistance means current decreases, and slowly it becomes non-ohmic. So this stage of a conductor is called non-ohmic because it's no longer obeys Ohm's law. This part is ohmic. So a single conductor can be ohmic and non-ohmic depending upon its behavior. So up to certain point it is behaving according to Ohm's law, it is ohmic, but after that it is no longer obeying Ohm's law, so it becomes non-ohmic. The relationship between V and I depends on the sign of V. Okay, so here you can see one more example. This is an example for diode, biasing of diode. We will study that in the diode chapter. But if you see that for positive voltage, the graph is something like this. For negative voltage, the voltage is something like this. But if you consider an ohmic conductor, the graph will simply like this. Okay, but that's not happening. that's not happening. So that means this is not a ohmic conductor, this is a purely non-ohmic conductor. Okay, this is an example of diode. Okay, this is an example for diode, and this one generally happens in a incandescent bulb. Old bulb, that yellowish color bulb, in that case you can observe this kind of graph. Okay, and the third one is the relationship between V and I is not unique, that is there is more than one value of V for the same current I. Okay, so there is one more thing, that if current and voltage for a single value of current you are getting two different voltages. This is also a non-ohmic conductor. Okay, so as you can see that the graph which is giving you, maybe apparently if you draw up to this point you might feel that okay, this is almost ohmic, slightly non-ohmic, but if you continue doing so after this point, okay, you will see that the resistance, instead of increasing, the resistance is actually decreasing. Okay, so it is going in this direction, means it is a negative resistance part. Okay, so you can see that this is called non-linear region. Up to this point it is linear, up to this point it is ohmic. Okay, so up to this point this is ohmic conductor, there is no problem. But after this, as you are going in, okay, it is not only getting non-linear, also for a single for two values of voltages you are getting same value of I, which is not possible. V is proportional to I, so voltage increases means current should also increase, but that is not happening over here. This is also a non-ohmic conductor, only up to this point it is a conductor, ohmic. Right now, if you also want to study from some offline classes, or if you want to recommend your family, friends, those who want to study from a good offline campuses, definitely Diksha producing excellent result in KCET and NEET and JEE. All the exams are taken care in our campuses, and if you want more detail you can go into the description given in the description box. There is a link given and you can go there and study, find more about them, and you can recommend your family, friends, etc. for studying offline campuses of Diksha. And you can see this is only KCET result because we are currently focused in KCET, but we have also done excellent result in NEET, JEE, JEE Advanced as well. Now let's move on to our lecture, temperature dependence of resistivity. Now resistivity, that is rho. Resistivity means rho, which depends on the temperature. It is not constant, it depends on the temperature. How it depends on the temperature? So this is a unique equation. So resistance at any resistivity at any temperature is basically given by rho naught. Rho naught is the temperature at 0 degree Celsius. Ideally it should be absolute zero, but for now you can say this is at 0 degree Celsius. Okay, 0 degree Celsius. So rho t is basically rho naught 1 plus alpha T minus T naught. T is the final temperature, T naught is the 0 degree Celsius generally. Okay, so this is how the resistivity changes. Now here alpha is called the temperature coefficient of resistance. Okay, now if you studied in heat chapter, linear coefficient, okay, linear expansion coefficient, volume coefficient, similar to that this is called temperature coefficient. Okay, alpha is given by rho t minus rho naught by rho naught into t minus t naught. Now most of the questions, problems that you will face actually are not dependent on rho. There are few questions might be, especially if you are going for JEE mains exam or Comet K exam. I have seen few questions which came directly based on the resistivity, not the resistance. But in most cases, in KCET exam, you will see the question given in terms of resistance, not resistivity. Okay, only thing you have to remember that all the resistivities will be replaced by corresponding resistance. Okay, RT is the resistance at higher temperature, R naught is the resistance at lower temperature, divided by R naught T minus T naught. Okay, now generally R naught represents 0 degree Celsius, as I said, not necessarily, but you can assume that. Now one more thing you have to understand is that this alpha, if you can calculate alpha from this formula, same alpha can be applied in this formula as well. And if the temperatures are not directly given, for example, here we assume that this is belong to 0 degree Celsius. If this is not 0 degree Celsius, it is given to random temperature, very high temperatures. Okay, in that case you cannot take the lower temperature as R0. Generally, if it is acceptable range, then lower temperature can be accepted as R0, but if the temperature is very high, you will not be able to use this as R0. So in that case you have to use this formula. Alpha is given by RT2. RT2 means the higher temperature, resistance at higher temperature. Also from this formula, you if you don't understand, this formula is given by RT equals to R0 1 plus alpha T minus T0. Okay, this is the same formula in terms of resistance. Okay, now resistance increases as you are increasing the temperature. Okay, R0 is the lower temperature resistance, RT is the higher temperature resistance. There is a plus sign, that means temperature, increasing temperature means resistance increases. Okay, so RT2 is the temperature, higher temperature, T1 is the lower temperature, so T2 is greater than T1. Okay, so T2 is the higher temperature, T1 is the lower temperature, divided by RT1 into T2 minus RT2 into T1. Let's see one problem which came in KCET. The resistance of a conductor is 5 ohm at 50 degrees Celsius and 6 ohm at 100 degrees Celsius. Its resistance at 0 degrees Celsius is. So what is the question? We have resistance at 50 degrees Celsius as 5 ohm and resistance at 100 degrees Celsius as 6 ohm. Okay, they asked you what is the resistance at 0 degree. Now this question is particularly easy. This question is particularly easy. Why I am saying so? If you see that 0, 50 and 100, these are the 3 temperatures, right? So what is the difference between these two? Difference between these two is 50, delta T, T2 minus T1. What is the difference between these two temperature? Again 50 degrees Celsius. And because the resistance values are small, you can say that whatever resistance increase happening in this range, the same resistance increase must happen in this range. So suppose this is X, this is Y, this is Z, resistances. So what is Y? Y equals to 5. And what is Z? Z equals to 6. Now what I am trying to say is that Y minus X should be equals to Z minus Y. Why so? Because the temperature gap is same. From 0 to 50 is 50, from 50 to 100 is also 50. That is why you can apply this simplified rule. So what is Y? Y is 5, 5 minus X equals to Z is 6, Y is 5 equals to 1, or X equals to 5 minus 1, that is 4 ohm. Okay, so correct answer is 4 ohm, option A. Now if you want to solve this same question in the previous method also, that you can do by calculating alpha. Alpha is given by RT2, that is high temperature minus low temperature divided by low temperature resistance into high temperature value minus high temperature resistance into low temperature value. Okay, from here you get 1 by 500 minus 300, that is 1 by 200. So this is the temperature coefficient, and then you can apply the value that R0 must be equals to R50 divided by 1 plus 50 into alpha, that is 1 by 200. Okay, so this is also another way to calculate. 1 by 4, so you will get the same value 4. You can check that out. Okay, so this is another way to solve it, but this is the easier way, just by using logic. I explained it, that's why it looks like little longer, but if you use the logic that temperature gap is same, 5 to 6 happening, so if you go back one step, it will be must be 4 to 5, 5 to 6. Okay, this is how you can answer some questions if it is easy. Otherwise, for difficult question, definitely you have to use the formula. Now, combination of resistance. Okay, we already did combination of capacitance. Now we are doing the combination of resistance. Now this is very common derivation. Derivation wise, this is not important at all. So I am just going to tell you what is the values for series combination. The values are just getting added, R1 plus R2 plus R3 plus R4. You have done this derivation in class 10th. Okay, if you have not done so, you can go back and check it once. And parallel combination is 1 by Req is equal to 1 by R1 plus 1 by R2 plus dot dot dot. Series combination means resistances are connected one after another. And parallel combination means voltage is, remember that in parallel combination voltage is same. In series combination current is same. Okay, so R1, R2, R3, R1, R2, R3. Right, now in series combination current is same, in parallel combination voltage is same. Now in our household circuit we use parallel combination because the devices that we use, they require a specific voltage to operate, not a specific current. Okay, and in fact even if one of the suppose one of the device is damaged, not working, then still the other devices will work as usual because this is a parallel combination. In series combination, if one of the resistance stops working, then entire combination will no longer function. Right, that's why parallel combination is preferred over series combination. Now when we are talking about only say two resistance connected in parallel. This is the symbol for parallel. Okay, series generally have no symbol. Series is series. Okay, you may have used this symbol in mathematics as well. So when two resistances are connected in parallel, you can use direct formula R1 R2 by R1 plus R2. This is a direct formula to calculate the resistance. Okay, now one important point in this formula, if you face more than two resistances, three resistances, four resistances connected in parallel, remember that this is 1 upon Req. This is 1 upon Req. Now I have personally experienced student solve this question and then they forget to take the reciprocal of it, because equivalent resistance will be the reciprocal of this. So in the heat of the moment when you are solving a question in a hurry, you are solving it correctly, but you forget to take the reciprocal, okay, or inverse. That's how you take the actual Req. So your answer will be wrong because you forget to inverse it to take the value. That's why for two resistances I recommend this formula. You can use this formula as well, but if you forget to take the reciprocal, your answer will be incorrect. This is a direct formula to calculate the resistances for two resistances connected in parallel. Now let us discuss about electrical energy. Now here we have a battery. Okay, we discuss more about battery in our next chapter, cell, but assume that this is a battery, ideal battery of say voltage V. It is connected across a resistance R. Some current I is flowing in the battery. Okay, then what is the energy displaced or energy dissipated by this resistance? Energy dissipated means whenever current is flowing through a resistor, okay, it can be a light, it can be a fan, it can be a AC, whatever electric component you are using, they all have a resistance. Now whenever you are using that device, okay, the device is actually consuming the electrical energy, and in return they are giving you light, maybe heat, maybe coolness, okay, for example AC. Okay, so all the components, they are consuming electrical energy. Okay, that is the source of the light or whatever you are watching. For example, you are watching the video in the mobile phone. Okay, now they are basically transmitting light. Okay, that light is transferred by the battery of the mobile phone. So this is the battery of the mobile phone, this is your mobile phone screen. So whatever current is passing through this, based on that there will be a different consumption of energy. For example, if you play a lot of PUBG in your mobile will get heated, right? Nowadays students don't play PUBG. Someone told me, sir, we play Free Fire, we don't play PUBG. Okay, so whatever game you are playing, that's fine as long as you are doing it in limit. If you cross the limit, then you are on your own. So the energy is basically vitamin. Okay, if you eat vitamin, you will get energy. So energy is basically VIT. Vitamin means VIT. Okay, or Vellore Institute of Technology. And power is the energy that is consumed per unit time. Okay, now unit of energy, unit of power is same that you have studied in your first PU, that is unit of power energy is joules, unit of energy is joules, and unit of power is watt, joules per second. Okay, watt, and it is joules. And if you see that there is another alternating form you can given here also there is an alternative form, I square RT. I like to ask student to remember this formula VIT, because this is the this resembles to the vitamin. So energy is vitamin, vitamin is energy, that's why and why it is written H, by the way, because it is basically talking about the heat energy. It is talking about the heat energy, so that's why it is written as H. Okay, it's also called Joule's heating law or Joule's law of heating. Okay, power is basically given by VI, Vodafone Idea. Okay, even though they don't have any power anymore, but power is VI, and it is also given by I square R, can be written as V square by R based on the question, based on the values given to you. Now, transmission of power, which is very, very important. So what is the meaning of transmission of power? Consider a device R to which a power P is to be delivered via transmission cables having a resistance RC to be dissipated by it finally. So basically what is the meaning of that? We have an electrical device. It requires a power P to operate. Okay, so basically your lamp or your light, that lamp is glowing, right? That lamp requires P power to operate. Older lamps used to have 100-watt lamp, 60-watt lamp. Nowadays 14-watt lamp, 9-watt lamp. These are the watt, that is the power consumed by the light. Now this is the light. You have a circuit which basically provides you the path to transfer this power. Okay, it can be power station, it can be battery, it can be your local power station, whatever it is, but there is a wire connected to it, right? The electrical wiring has to be done, right? It is not wireless. So through this wire some current is flowing, and even though most of the time we ignore the resistance of this wire, these wires are actually not resistance free. They also have some internal resistance. Okay, so that resistance we are talking is RC. This is the resistance of the components. Okay, RC to be dissipated by it finally. If V is the voltage across R and I is the current through it, so if V is the voltage across the device and I is the current, then P is equal to VI. This is the power dissipated by this device, right? Then the connecting wires from the power station to the device has a finite resistance RC, the power dissipated in the connecting wire. So when they are delivering this current to your device, they are also losing some power to delivering this power. So basically what is the meaning of that? So the light which is glowing in your head, it requires certain amount of power to operate, but to provide that power you actually require more power to supply, so that the remaining power can dissipate in the path. Okay, and that power which is wasted is given by this. The wastage of power is given by PC equals to P square RC by V square. So if you see that, if you can keep this RC very low and if you can keep this voltage very high, then the power loss basically decreases. That's why when power is supplied from the power station, they generally supply in the kilovolts. Resistance you cannot decrease. Okay, resistance up to a certain limit you can decrease, beyond that you cannot decrease the resistance. But what you can do, you can increase the voltage. That's why it is said 2000 volt keep away, 440 volts keep away, right? Because when it is getting transmitted, kilovolt line, the big lines, if you have seen across the railway station or across the highways, okay, there are big supply lines. Those are kilovolt lines. They are very dangerous. Now let's see one question. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease. Okay, so voltage and power is given. So voltage is given by 220 volt and power is given by 100 watt. Okay, they ask you if the power if the voltage is dropped by 2.5%, then how much will be the power will change. Okay, so what formula we will use? We will use the formula power is given by V into I, or you can say V square by R. Now if voltage changes, current will change, right? So you cannot use this simple formula, you have to use this formula, because resistance is constant. Resistance of the bulb is constant. You can even calculate from this value. So resistance is constant. Now there is a trick to solve this question, because it is given in terms of change. Okay, changed by, dropped by, increased by. So if the change percentage is given, you can use this dp equals to 2V dV by R, right? 2V dV by R. So this is the differential. This is called differential, right? Now what we will do, we will do this dP by P. dP by P into 100% is basically change, that is 2.5%. Okay, or dP by P is nothing but 2.5 by 100. This is how we convert percentage into fraction. Okay, this is the percentage change in the power. Now if we do dP by P, what we are getting? If you divide this side, we will get V square by R, right? P is V square by R, so that's why you are doing it. So you will get this as 2 dV by V, 2 dV by V. So this is the percentage change in the power. Okay, this will be the percentage change in the voltage. Okay, so voltage is dropped by 2.5, not power, sorry, power is not this, voltage is changed by 2.5%, sorry. So dV by V is given by this. Okay, dV by V is given by 2.5%. Let me keep it as percent, remove this 100 and keep this as percent. So dV by V is 2.5%, so we will multiply 2.5 and we will get this as 5%. So correct answer is 5%. Okay, this is a way to solve this kind of question, convert them into differential and solve it. Now these are the homework question. So this is as I was talking about, this is a 10% increase. Try to solve it and mention that in the comment below. I will be solving this question in our PYQ session. So if you are not able to solve this right now, you should check our PYQs, KCET PYQs. There this question will be solved. And if you want to download the PDF of this lecture, then definitely you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description. Here is another question, second question. Pause the video if you want, write it down, solve it, and right now you mention the answer. Right now, don't wait. You have to mention the answer right now. Pause the video, solve it, write the answer right now. And obviously for the lecture PDF you have to download, you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description of the video. And if you want to feature in one of these beautiful students along with us in the next year KCET result once it is announced, and you have to continue following our channel and subscribe to our channel. If you have not yet followed or subscribed to our channel, then don't forget to subscribe to our channel. I'll be back with part 2 of this video very soon. Till then, bye.